In this video, I'm going to show how to use mathematical induction. We're going to use an example of the sum of the natural numbers, which we're going to define as p of n. And we want to prove that p of n is equal to 1/2 n times n plus 1. The first step is to show the base case to be true. For this problem, our base case is n equals 1. We are going to substitute 1n for n. And in the formula, we're going to get 1/2 times 1 times 2, which will equal 1, which is in fact the sum of the natural numbers starting and ending at 1. The second step in mathematical induction is assume that the p of k case is true. K is replacing n. So we are stating that the sum of the natural numbers from 1 to k is equal to the equation 1/2 k times k plus 1. The third step is to show that the next term to be true. So our next term is k plus 1. I'm going to define what p of k plus 1 is. So it is the sum of the natural numbers from 1 up to k plus 1. Now I know that the sum of the integers from 1 to k is equal to 1/2 k times k plus 1 from my second step. So if I add that statement plus k plus 1, I need to do some algebraic manipulation. So common denominator, expand out the numerators of each, combine like terms, factor the numerator. P of k plus 1 is equal to 1/2 times k plus 1 times k plus 1 plus 1, which does match my original equation of p of n is equal to 1/2 n times n plus 1. I've proved that the first case to be true, I've assumed that my statement is true, and I've proved the next case to be true. Then I can say that my original proof is true with mathematical induction.